All right, we're back. It is COMP305, that's Game Programming 1, and it's the fall 2016 semester at Centennial, and we are week 2, part 2 of our broadcast, the afternoon of Saturday. Right? We always do the afternoon class or record the afternoon class because first half is a bit of a dress rehearsal. All right, let's go into our the PowerPoints. I have put a couple of PowerPoints up online for you. I want to look at part 1 for a second, and the reason why is because all around order of event functions for the Unity game engine and also the Unity game object class. I want to talk about those two things, right? So let's talk about this. So I want to talk about Unity's event functions, the game object class, and the input class. Those are the three things that we want to look at today. To do that, what I want to do is I want you to bring up Unity, please, right? So if I go to Unity, do this together, right? So here's Unity. I want to create a new project today, so I'm going to go New, right? And notice how I have my project name here, COMP305, fall 2016, lesson 2B, because you guys are the B team. And then click Create Project. Notice I turned analytics off. I don't have it on like this, it's off. And then click Create Project. You have to be logged in for you to do this. All right. When the project is created, notice how I have my setup. Now, some of you, if you're here for the first time, won't have this setup. It'll look like the default setup. This is bad, right? Not because it won't work for you, but because I don't find it as efficient when it comes to work. So what I want you to do is I want you to go to default, where it says on the setup type, go to 2x3. This is the one I want you to go to, 2x3. We're going to modify our setup. We're going to pull our game tab, like I did last week, up to the next to the scene tab. Again, I'm just grabbing the tab. Notice that I can move these around. They're just floating. I can tear them off and move them around, right? I'm going to move the project tab underneath the hierarchy tab, like this. Underneath there. There we go. So I'm going to take the project tab, move it underneath this tab here. To park. I want it to park in here. So there's a couple ways I can do that. I can move it so that it is here, part of this tab, or I can click on the hierarchy tab and then move it in underneath, like this. This is what I want it to be. Now I want to scrunch these up to the right. So the right has all this stuff. Add in something else we're going to do, which is our console. I want our console, and the way to get the console is go to Window, Console, or Shift Control C for the PC, Shift Command C for the Mac. The console, I want you to park that one next to these ones, like this. Here we're going to set up our environment, right? One more thing I want to do is I want to take the slider bar, the slider, left, over here. When we create our project, the first things I want you to do with your project is under the assets folder, we're going to create all of our folders that are required. And just like we did last week, for those people it's a review, we're going to right click and go create. The first folder we're going to create is the scripts folder. And then we're going to create our scene folder, scenes, so they come up on top. And then I'm going to create another folder, which is going to be sprites. We're going to use that today. And another folder to be prefabs. Here we go, prefabs. Okay, so scenes, scripts, prefabs, and sprites. Those are the ones. For today's lesson, what we're going to be using is an asset, a bunch of assets that I've put up on GitHub. Assets, and follow along with me. I'm just going to close these down for a second. You need to go to GitHub college, so /GitHub/Centennial College. And if you notice, there's something called the twin stick shooter assets. So please download these. Do not watch me or learn how to do this stuff. So please do it with me. Your Unity doesn't work? What's wrong? Okay. Can someone give him a hand? Thank you. Twin stick shooter assets. And if you notice inside the twin stick shooter assets, we have a couple of assets that they supplied in the book. One of them is the background ping, as well as the enemy ping file, right? This one. And also the player ship PNG. This is the one we want to use. This is all up on GitHub. Centennial College twin stick shooter assets. That's where it is. Okay, it's up on GitHub. Please get them from there. What are our assets? Let's assume assets. Here they are. Here's my twin stick shooter assets right here, right? And what I want to do before we start, and I know I'm doing this a little bit differently than I did this morning, a bit. With this one, and I'm just going to put it up here. I want to take this one here, and I want to kind of combine it with this one here. There we go. And is that the right one? Probably not. Do I both open? I do. All right, let's just close this one down. Sorry, just want to make sure I got this right. So I want to grab this one. And I want to move this closer to this one. There we go. Okay, so what I want to do is there's a couple ways you can import these assets. One of them is if you go into the sprites folder. Here's my sprites folder, right? Are you guys okay, or is it down? Machine itself? It's broken? Okay. All right. Going into my operating system. Here's my operating system. And what I can do here is I can drag and drop. So I can select my ping files. So my background file, my enemy file, my laser file, and my player ship file. Drag and drop them in here. I can do that. I can also go import new asset and then point to these assets as well. I can do that. My recommendation, though, is we drag and drop. That's just the easiest way. So I kind of drag and drop them in here. And they appear inside my sprites. Okay? So that's what we're doing here. Our assets are right in here. That's what I've done. Okay. Also, immediately, what I want to do is under scenes, right? Notice that right now, when we first kick off Unity in 2D, right? We have a main camera. That's all we have. Title for our scene. And what I want to do is I want to save my project and save my scene. So first, I'm going to save my scene as, and I'm going to point to the scenes folder. Here's the scenes folder. Scene as main. Press enter. Okay, there's scenes, there's main. So we got my main scene right here. I also want to save my project. So save my project. So I've got save my project, save my scene. Now I'm going to, here in Unity, I'm going to stop Unity for a second. And I'll tell you why. File. Because I can't upload things to GitHub, everything being open, okay? I can't do that. The only way I can do it is if I close down, my, then upload to GitHub. So these are the steps. First, I need to create a space for my lesson, my GitHub repository, right? Right now I have this one from this morning, but I want to make a new one. So I'm on GitHub repository, and I'm going to name the repository, so COMP305 fall 2016, F2016. and then lesson 2B. Lesson 2B. That's what it's going to be called. And then I'm going to press create repository. Now you're going to see it. It's just going to be a container up on Centennial College. Nothing else here. I can follow these instructions if I wanted to on the command line. And that's pretty much what I'm going to do. Let's make this happen, right? So how do I do this? Go to my command line. And I want to go where my Unity projects are all saved. Now mine are saved under my desktop Unity projects. You might save yours somewhere else. Well, as an example, if I go to my desktop, and I'm going to pull up my desktop, and then you find a window just to make it easier. Here's my desktop. Unity projects. I have a project called COMP305 Lesson 2B, right? This one. I'm going to go C3 and then drag and drop the name of my project into my terminal. Now, it works the same on a PC, believe it or not. And then press enter. So what it's going to do is going to take me right into that space. So I don't have to swim around and find out where it is, okay? It's you know, somehow it's challenging. When you see some of this stuff, you're like, wow, it's crazy how it seems so easy. You can see that the full path, Thomas desktop Unity projects, COMP305, blah, 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 right? Oops. All right, so now that I'm there, I want to create a GitHub repo. And the first thing when we create a GitHub repo is initialize GitHub, right? So it's git init is the command. Now, in order for you to make this work, you need to have GitHub installed on your system. So if you're working at home, you need to have gone to something like git-scm.com, GitHub for your machine. Now, for the Mac, you're in luck because GitHub is already installed on the Mac, right? However, if you're a PC user, you need to install Git for your machine, right? And this is the best place to do that, git-scm.com, right? All right, that you have Git working, right? And all the machines in the lab should have Git working. You should be able to do something like this, Git. What this does is it initializes the repository locally. So it creates a space where we're going to take a snapshot of all of your files, your project files. The snapshot itself is going to be saved in the .git folder, the hidden .git folder on your machine, right? An example of this, if I just do an ls in, you can see that I can't see it. Assets, library, and project settings, right? But if I do a ls-al to show me all the files, I can see that I have a hidden Git repository called .git. This is exactly the same on Windows, except you wouldn't use the same commands. We can do a directory. If you look at the directory, you can see that the directory in Windows has this .git folder, and this is where all the snapshots are held. So I want you to think about Git like this: a system that we use to keep track of our files, right? There's 3 uses I talked about last week for GitHub. One of them is backup collaboration, where you can work with somebody else. The third one is version control, right? Okay, so those are 3 reasons. And like I said before, also do so your private repositories. Like I said, you can do your private repositories by downloading the GitHub Student Pack. We talked about that, right? Also, right now, what I'm going to be doing is I want to link up right now my local repository. I've only initialized it. I want to add all my files to the staging area. The staging area is almost like a place where I'm telling GitHub, I want to say, hey, files to go into my repository. So I'm kind of listing the files. It's almost like a middle step before I actually put all the files, take a snapshot of the files. I'm telling GitHub which files I want to take a snapshot of. So I need to do this. The add command tells me on which files I want to add. And if I press dot, it means everything in the folder, right? And all the other folders inside. And this added everything to the staging area. Next, I want to make a commit message. So I have to say git commit -m for message, initial commit. It'll come on eventually. All right, so what is this? Commit is just a fancy way of saying, or Git's way of saying snapshot. I want to make a snapshot of my files in their current state. So that way, when I make changes to my files, I can track my changes. So git commit this snapshot. M is the message that I want to make a friendly name for the snapshot, and I use the -M option to do that. And in quotations, I put in the name. And usually for the first commit, it's either first commit or initial commit. Those are the two conventions we use when we use GitHub. First commit or initial commit. I'm using initial commit. I'm pressing enter. Now you're going to see all these files that have been added in the repository right here. I'm going to clear the screen. Okay, so now I've done three things. I've git init, which is initialized. I don't know what to do. It's right here, right? Git init, which initializes the repository. Git commit -M. Now they use first commit. I use initial commit. Same thing. I also, instead of adding the README file, I said git add dot, which adds everything. So not just the README file, but everything else. I could certainly type them in, but why? I can just copy them and go back to my terminal and then press enter. And what this will do is it'll say, I'll add the remote. That's the remote GitHub repository on GitHub on the service, on the cloud service. And then what I'll do is I'll use the git push to master. Origin is this, my local repository, to master, which is my master branch up on GitHub. What I'm actually doing is I'm saying, hey, my origin, this origin, I can call this, by the way, whatever I want, remote, or whatever, is this. This is my origin right now. This is the remote repository right here. So I'm really saying git push -u for unconditional, right, in the master branch. Push all this stuff that I have. And that's what we've done. And if I go back to Git and if I press refresh, now you can see that I have my Unity project up on GitHub. These are the steps. You cannot use Unity. There's no GitHub built into Unity, like there is with Visual Studio, right? And you can't do this while Unity is open, because Unity also has open meta files that it uses for tracking and other things. You would get an incomplete project up on GitHub. Okay. The other thing I'm going to ask you to do today is do a build. Let's do a build with Unity. Now, in order for me to do that, I'm going to have to launch Unity again. So here's Unity. In a little bit of a different order than I did this morning, but only because I learned this is probably the right way. So here's my what I want to do is, or sorry, my Unity project. I want to go to sprites. Notice that I got my player ship. I have my my sprite, which is my texture type, which is 2D and UI. This is what yours should be too. A sprite that's 2D and UI. If it's something else, like if it's something else that's in here, change it to sprite 2D and UI. Unity is the one that set these things up, right? I didn't set them up. It was done automatically, right? If you want to make a change, you can always go down here to apply and apply the changes. What I'm going to do now is I want to pull my player ship onto my scene. Here's my scene. And if you look, 2D camera. Last time we did this, we did a 3D camera. Well, actually, this is actually 3D too. Here's my camera, and you can see that my camera is looking at it as if it's looking into a box, right? This is my camera. So my camera is over here. I want to rotate around this whole scene. I'm going to rotate this thing. You can see that's way down there. It's looking. That's the destination. And this is where my camera is, right here. Camera. If I go F to frame my camera, you can see that this is what my camera is looking at, way down here. That's for perspective. Why? Planes. And we'll talk about this in a second, right? I'm going to bring up when I go back, I'm going to bring up this Sketchbook Pro for a second, all right? Like I'm drawing on the blackboard or the whiteboard, all right? So let's suppose, if I have a little point, let's suppose this is the origin of my camera, all right? This little dot that I'm making, right? And I want you to think about my camera is looking out from the origin. who took advanced graphics, you're going to totally align with this one because you know what this is already. I'm going to take my ruler object, right? With my ruler object is, I'll tilt it up a little bit. I want to draw the camera, what the camera sees, right? So what I'm going to do is I'm going to take this and draw what it's looking at. So imagine the camera is looking out from the origin like this. And this is what it sees. Well, the camera, the great thing about the camera is it also has, there's also two other things we have to think about when it comes to the camera itself. We have to look at is something called the near plane, this plane right here, right? And there's something else way over here that the camera looks at called the far plane, right? Now this is kind of skewed, but I want you to think about this. The near plane, fading away too. The near plane is, what happens is the camera can see the near plane and the far plane, okay? So I want you to put this in there. So here's the near plane, right? Here's the near plane. We'll move it around for you. So this is the near plane, this line right here, right? And there's another thing called I know this is a little bit of we need to understand the theory before we actually get into it. All right, so we've got our near plane and far plane. This is important, right? What we also have is something called the field of view. We're just going to call it FOV, field of view. Here's our field of view right here. Makes sense? So near plane and far plane. The camera cannot see anything closer than the near plane. Camera, and this is the near plane. This spot in here, blind. The camera can't see it. And anything beyond the far plane, that either. It also can't see over here, behind the camera, or somewhere else where the camera is not pointing. Okay? So I want you to remember this because if I test you, plane, you should understand what field of view is. My field of view is only what the camera can see, right? It's a very important concept in advanced graphics. We talked about this. This is nice. Well, how does this relate to Unity? Because the clipping planes is the exact same idea. Our 0.3 at 0.3 Unity units and less, it won't be able to see anything closer than 0.3 Unity units. But here's this, look, the camera can see 1,000 Unity units away. Do I really need this for a 2D game? I can probably reduce this a lot more. Like for example, if I look at what I'm looking at here, this long square or cuboid, I cut this down to 10, right? You can see now that I have how far the camera can see. Monkey with this today. We're going to put it back to 1,000. But I want you to understand that this is what the camera sees. It's an orthographic camera. That's the projection. The size of the camera is 5 Unity units, or 5 meters. It's pretty big. All right? Let's go back to 2D. So when I look at the 2D camera, all it looks like is it's a flat plane. That's what we're seeing. I want to drag and drop my player ship surface, the play surface. There's 2 ways I can do this. I can drag and drop it into the hierarchy, which is this window right here, or I can drag and drop my player ship directly onto the scene. Thank you for staying. Figured out? Excellent. So let's do the player ship directly onto the scene. I'm going to take the player ship screen. There it is. Notice I get a plus. You might get something similar. There's my player ship. If I press the F key again, I can frame select, and it'll just zoom me right into that player ship. All right? Let me just zoom out again. All right. Now this is a problem. I want my player ship to be at the origin. And notice that I get some funky the player ship. And by the way, I'll explain what I'm doing later on because we're going to go into detail. I'm just doing this in advance so that way I can do another commit because I know people have asked me to do GitHub a couple of times. So here's what I'm going to be doing. So I'm just changing the order of my lecture from this morning. A position of my ship in X and Y coordinates is -3 something and 1. Why? Because from my ship is right here. Typically, we'd be expecting that the origin would be at the top left corner of the screen. Not so with the setup we have right now. Right now, pixel perfect units, we're using a ratio. And to understand the ratio, if I click on the player ship itself, pixels per unit is 100 to 1. I have 100 pixels, or 100 pixels for every pixel in my ship. That's totally different. It's a different scale than what I'm used to doing. Because I'm using Unity units for my origin, it's 5 times what that would be, right? So I've got 5 meters. It's not pixel perfect at all, right? And we'll do a pixel perfect game next week. There's a disadvantage to that. What would be the disadvantage to a pixel perfect game? What if I made a game that's 640 by 480? What would be the bad thing about that? How about Alex, the guy who's the smart guy in the corner over there? What'd be a bad thing about a pixel perfect game? If I wanted to render it on a different resolution, you're right, then I would have a problem. If I wanted to put it on a mobile device, right, it's pixel perfect. It's 640 by 480, always. This is scalable, right? Now, there are some inherent problems when we first make 2D games scalable like this because of our thought, the way we think about units and how to allocate or assign our objects in two-dimensional space. This ship is relative to the 0, 0 point is. But if I click on the ship, you can see that my current position is, which is to the left of center, and 1.57, which is above center, right? That's why it's positive and to the left. If I put it in this quadrant, this part here, you can see that it's positive X and positive Y. If I put it to the bottom left quadrant, it's negative X and negative Y. And if I put it to the right bottom quadrant, X and negative Y. And this is all because of our origin being in the center. Is relative to the origin in the center. I want to put it in the center, and there's 2 ways I can do that. I can certainly type 0 and then 0, physically typing what I want, and put it in the center. I could do that. Instead of doing that is, if I undo those changes, I could just go to the gear, and that would reset my ship to the center. So those are the 2 options. Okay, let's frame select the ship. I'm going to press F for frame select, and it'll take me right to the ship again. There we go. This is our little ship. Let's press play. And if I press play, just be in a blue background like this. Okay, nothing too exciting. And we kind of did this last week. But let us build our WebGL, use our WebGL build. Because remember, I want you to do a WebGL build, right? So I'm going to go File, Build and Run, and we're going to choose WebGL target. Build WebGL. Why? Because remember, I want to be able to run it in a browser. I want to be able to run your game in a browser so I can test your game easier. Build and run. And now it's going to ask me, well, where do I want to put this thing? Now on the PC, it's slightly different. But here, what I want to do is I want to kind of create a new, and my folder is going to be called builds. Click create. On the PC, it's kind of a one and done. I'm going to call this WebGL. All right, so slightly different what I'm doing here. When I do that, when I build my WebGL build folder, it's going to take some time to do this. That's why on a test, right? On a test, until for the 4 hours or whatever, you're going to only have 3 hours and 30 minutes because this takes about 10 minutes. This simple graphic. So can you imagine if we had more, which we would? A whole slew of graphics, right? So it takes time for us to convert and manage our assemblies and change them, to C++, convert everything to JavaScript, right? That we need to convert, run it on the web, all right? That's what this is doing, right? So please, when you build out your assignment number 1, don't forget to do a WebGL build, because that's one of the 3 requirements that I have for your submission. A WebGL build and an external document. And you can do the external document either in GitHub, in the README section, right? Or PDF. Now it's native compiled to JavaScript. So it's taking some time, right? Hey, I'm showing you this, guys, so that you can see that this takes time. It's not something that I want you to think of it, that's a snap your fingers and it's done. And I got a pretty powerful computer, right? Relatively, right? I've got a 16 gigs of RAM. It's the 5th generation i7, not a 6th generation, right? With a 1 terabyte SSD, right? So it's not like I'm getting bottlenecked anywhere. Processing power that I need, right? So you can see that it's still running on your machines in front of you in the lab. It doesn't happen any faster, even though you have a laptop. It doesn't matter. It takes time. So please give it the time it needs. If I cut you off on your exam and I'll say, okay, now time to build, to do your WebGL build, it's going to take time. Mine's done. Right.
Just on the GS.
Yeah. So you see how fast it is compared, right? So there's my game, and you can see that it's popping up in a browser window now. Click a little bit lower so you can see this is the default, right? So this is my game. Right now, it's just a blue background with my little ship. Okay, this is a great place for me to upload to GitHub again, because I've done a change. I've added my WebGL build. Now for you, we're going to do, in the future iterations of this, we're going to omit your WebGL build, so you don't put it up on GitHub. I don't need that. I only want it in your eCentennial. That's the only piece that I want you to upload to eCentennial, just your builds folder. Because it's massive. That's why it's huge. It becomes really big, your builds folder, right? But it's much smaller than your entire project. Imagine if I have 40 or 50 assets, but I only need 10 of them. If you give me your entire project on eCentennial, that means it might be 500 megs, right? Your build, it might only be 100 megs, right? That's why. Okay, how do I do that? So I've got my assets. I'm in Unity. I need to save my project, save my scene, right? Here, save my project, save my scene, and I want to quit Unity. I'm quitting. Why? Because I cannot upload to GitHub without quitting Unity. If you try that, it will fail. Now, I'm here in my Unity branch. Got any changes? Add dot. Okay, it's taking its time. See how long it took? It took a bit of time there. Git commit -m, and I'll say something like, reclaim, when I stopped Unity, I reclaimed 4 gigs of memory, right? Just by running Unity. -m, and I'm going to say something like added WebGL build. That's all I really did with a bit of an asset. And then press enter. Got added in, right? And now I'll say something like push. Actually, I'll clear the screen so you can see it. Origin master. So I'm going to go to the master branch and then press enter. And what this is going to do is it's going to take my local repository. Right now, automatically, already, I have 14. My project is 14 megs with my build, right? And it's 14 megs. You're going to get away with something larger in 3D without half a terabyte, all right, or something crazy. If you really want to run in a real game scenario. Now, example: let's say I build a AAA game. Do you think my assets are going to be any less scripting and everything that's less than 500 gigabytes? Right? Probably not. It might end up being only 30 gigabytes, the game, or 60. What's a 60 gigabyte game that you've downloaded lately for your Xbox or PlayStation? There's a bunch. What have you downloaded lately? Fallout 4. Well, 50 gigs, right? If you were to do that, that's a full-fleshed, completely like uncompressed version, right? But I guarantee you, on your little, the DVD is compressed, right? Even though it's like a bunch of gigs, it actually, when you log in and you install Fallout 4, it actually installs other stuff too.
That was on disk that actually had information on the disk.
Can you imagine? It's compressed. Yeah.
So
So I want you to think about that. I want you to think about, like, when you actually create a game, assets. Chances are when we're creating our stuff, we might have other things in there in your project. You might have other builds, you might have had other branches. I don't want all that stuff. All I want is your WebGL build. Hey, it finally did it for you guys. And your WebGL build, and I also want your, at the end of the day, right, your files, not including your builds folder, up on GitHub. If I want to see your code, I can see it on GitHub. And if I want to run your stuff, I'm going to run it through eCentennial, right? Because it's there. eCentennial, I double click, boom, I can run your stuff, right? All right, so I've got everything up on GitHub. Let's take a look. I had one commit before because I did my initial commit. If I refresh, I now have 2 commits. And you can see that I added my WebGL build. It's a much bigger project that I've done so far. Okay. If I hover over these little lines, actually, you can see that these little, I can hover for my language details. These are the language details. I have JavaScript 53%, WebGL build. My HTML is 23%, and my CSS is 23.4% because I don't have any script here yet. I don't have any C# at all, right? So that's what it's classifying. It's classifying this thing as a web, which it's not yet. Okay, so I wanted to show you this piece because it's important when we start off. Unity for a second. So I'm going to bring back Unity. I want to talk about this stuff with you because so you're not blindsided when it comes to putting stuff together. It takes a while to make things work properly. Project or my PowerPoint. These 3 things: the events lifecycle, the application lifecycle, name object class, and the input class. So let's go into this. There's different phases. These are the different phases for the execution order. So first we do the editor phase. Then we do the first scene load, the first frame update phase, in between frames, the update order, rendering, coroutines, and so on. Taken right off of the Unity website. I want to bring it up so you can see it. So the first phase is the editor phase, where we do a reset, right? So reset is called in the editor when the script is attached or reset. Then we have our initialization phase when we run our game for the first time, right? This, guys, I'm so sorry. It's concepts and a little bit of theoretical stuff. But we need to talk about it or else you won't understand when it comes down to actually using it in Unity. This is the best way to start. So we have our awake function. Our awake, all these, by the way, all these little things that you have in these boxes are just functions that are part of the mono-develop framework, right? The mono-behavior framework is what every script inherits from. So mono-behavior allows us to do things like on enable and start. We probably won't use awake too much. Start is one of the core functions we're going to always be using, right? So start is where we do our initialization, where we initialize our variables. Move forward, we also have fixed update, right, as an example. And we also have some events. We're going to talk about this. Hey, here's something that I want to ask you. We have fixed update. I want you to think if you can figure this out. We have fixed update, we have update, and we have late update. You guys did that primer on Unity with thing. What's fixed update? What is it for? Why fixed update over update? Huh? It's every frame, but why would I use fixed update over update? That's right. It has to happen every frame. Fixed update always happens at a specific interval. Update, it's best effort to happen at the same interval, right? So why would I want to do that? Fixed update primarily we use for physics. Remember this mnemonic. Fixed update for physics. Fixed update for physics. They both start with the F sound, even though they're spelled differently. Fixed update with physics. Regular update with logic. Other logic you want to put in. And that's what we do every frame. So I want to think about an update as the place where I'm going to put my logic, because it's going to trigger every frame. And I'm going to be running my stuff at 60 frames per second, right? That's 60 times I'm going to run my logic every second, every 16 milliseconds approximately. 60 frames per second. So then we hit our physics phase. Our physics phase, we have our, like I said, our fixed update, and we also have a couple of events: the on trigger and the on collision. We'll talk about those in a second. Actually, it might be a good place to talk about them now. Board for a second. So I've got the near plane and the far plane. This is, I've talked about this. This is talking about the camera, right? What I want to do is I want to do a new file. I want to think about collisions, right? So what if, maybe I'll use fireworks for this one. And some of you have had this kind of lesson before, if you've done COMP397 or whatever, or maybe you were taught it as part of something else, but I'm going to talk about it again because we have to be on the same page. So I'm going to go to open, actually, yeah, and I'm going to open up my COMP305, and you can use whatever editor you want to kind of demonstrate this for yourself, right? I'm going to go into my player ship. I'm going to open this up. And I'm also going to define a new area. Let's say we'll make it 1,000 by 1,000. So think about this as my background. For now, this is in pixels, but I want to take my player ship, copy it, and I want to put it in this background so you can see the player. So this is the player ship, right? Background, just to make it so it's more interesting. I'll make my background canvas color white, so you can see the player ship. If I zoom in there, now that the player ship has this rectangle that goes around it. Think about this as the collider, right? I got my collider. I'm going to load up my enemy, right? Which is one thing we have to look at as well. Here's my enemy. My enemy ship is kind of round, but even though it's round, circular, right? It's not exactly round. I'm going to put it here with my other player ship. Tell me now, as we zoom in, right? I'll make it big so you guys can see it. That's why I'm doing this. So please bear with me. Collision. How about why? We don't have, but can you see the collision visually? Is there a visual collision? Well, we do have a collision when it comes to these. These are intersecting, right? We've got overlap rectangles. And so in the game, engine or whatever, if we use rectangular or box colliders, if you will, right, we have a collision, right? So the idea is that there's different kinds of colliders, right? There's different shapes for the colliders, number one. And there's different types of colliders. If I had a physics type collider, right, I would use on collision enter. On collision enter means my ship is my sphere, and they should, by physics, we should just bounce off each other, right? Because we're using physics. Like, for example, my sphere, maybe it comes into here, bam, it bounces off and keeps going. Collision, where my body, the object itself has some kind of rigid body, or feels like it's solid. Physics collision. And typically what we use for those is, we can also use other ones. We use the box collider, right? And what we do when we have an event that triggers, we use the enter event, right? If I stay, the on collision stay event fires. If I leave, exit event triggers. Events: on collision enter, on collision stay, on collision exit. Those three. Sometimes though, this, right? It's not about this kind of collision. Sometimes I want to trigger a collision, right? Because I want to have a different effect. And a bunch of that effect that I kind of brought up this morning was based on something like if I was going to do a platformer instead, right? Or maybe I want to have a trigger effect. I don't really have a collision necessarily, an effect, okay? By the way, these things that I'm talking about are both semi-interchangeable. Here's my, my drawing board here, right? I'm going to try to attempt to draw some kind of funny platform. So here's the platform. I'll show you in a second what I'm talking about. We'll use the ruler to draw it as straight as possible, right? Just to take care of my lack of skill. And if you look at here, there's the platform, right? Nice and easy. So we've got our platform, right? And we have our character. He rides on top of this platform. Crosshairs as my character, right? And if I touch the platform, right, that's a collision event. Enter. And I continue to collide on collision stay. If I jump and then I land back down, it's on collision exit, because I'm doing all those in that order, right? Leaving, coming back, and then staying, right? So those three collision types. Okay, that's that collision. But what if I have many platforms? Many platforms. And what I want to do, right, as an example, is I want to cut this out. That's what I want to do. And I want to paste it a bunch of places. So paste it. And what I want to do, I want to move the other one. So here's the other platform. And let's say the final platform, just putting it out there, right? I know it's funny. Maybe at the end of the platform, there's a door, right? So here's the door of my platform, and we'll make it a cross. So, you know, this is like the end door. We're going to get there. And by the way, this is ... So there's lots of platforms. We worked really, really hard. And I'll ask, you know, the gamers in the room to help me out. And then you get to this, and somehow you get something that drops onto you from here, and you die. Or you have to start at the beginning again. So your poor guy has to start over here again, right? And this, to me, is a pain in the ass, yeah? So sometimes what we have is we have something called a checkpoint, right? And the way we do that is, let's suppose the checkpoint's here, a collision, some kind of a zone, if you will, right? That's a trigger. It's not a physics collider. It's a trigger collider. So when you pass through the trigger, right, it causes our checkpoint. It says respawn after the checkpoint. He's not going to respawn at the beginning anymore, right? Which makes gameplay a little better, right? So you can actually, you've gone through some of it. You figured out one puzzle part of the former, and now you get to figure out some other part of it, and then you can figure out the last part. If you're at the end, finish the last part of it from the beginning again, because it's a pain in the ass, right? Trigger collider. The other thing we use trigger colliders for is some kind of plate. So the character runs over the pressure plate, and then there's a trap that falls on his head, right? Pressure plate, trigger collider. He doesn't actually base collider. It's a trigger collider. He triggers the trap, right? That's another reason. By the way, like I said, you can have multiple colliders on one object, as well as a physics kind of collider, which is the circle collider or the box collider or whatever. Okay, so again, we're just talking about concepts here, and I'm talking about them because when we move into things going forward, you're going to see that these things are going to come up again. A bit about game concepts today. All right, let's go file new. What if, though, I have my, actually, let's save one of my platforms. Here's my platform. And what I'll do is I'll just hide that one. Let's say, as an example, that inside this layer, character, so here's my character, I have my head, but he's got a weird shape to him. He's kind of looking like this, right? I can't quite do characters that kind of look like this, right? I can't quite do a box, because if I was going to do a box collider on his entire body, right, then, you know, inside the box, and I would have that problem with having a problem with visual collisions. It wouldn't look like I'm colliding anymore, right? So what can we do? We can split them up. We can say that his legs are a collider, middle part is a collider, and we can say, for whatever reason, that his head is also a collider, right? And notice that it's a little bit offset. Why? Enemy that jumps on his head, right, then it'll hit properly. Otherwise, it would probably hit this, which wouldn't work. Or probably the box would be out to here. Guy at all, but somehow here's the collider, right? It's going to happen right here, which there's no collision, right? So I'm pointing this out because multiple colliders on an object. We don't have to, at all, in any way, we don't have to use a single collider for an object. Again, we can use this example of the idea of this platform, right? And the platform itself be as thin as, right, something like this, right? So almost like a thin collider. We don't do that. Or the physical platform that we see front, it's layered in front. It's just a covering, a skin, if you will, right? But the actual collision is happening. And let me see if I can draw this shape for you. So imagine if, I'm going to choose a different color too. We'll choose green color. There we go. So imagine if, and I'll choose another layer. There we go. In this layer, imagine if that we, there we go. Imagine if we have this shape and the actual collider is here. So it kind of comes to, bear with me here while I choose the right shape here. So again, what I want to do is I'm trying to demonstrate to you guys how this all works, right? So let's suppose that I have this shape that looks like this. This is the actual collider. The actual platform looks like this, the green, right? But the physical platform that's in front of it looks like this platform, layered behind or hidden even. But this is the physical collider not on trigger enter. Here, he's going to hit this top part of the platform. But actually, even if he hits this part of the platform, he's going to collide. Uh-oh. Why is this a problem? Because if I have my character, and I'm going to draw him for a second, and not with those things. I'm going to try him without using this. But if I have my character, and here he is, the platform over here, right? What happens? A couple ways it happens, right? Because this top of the platform and this side and this bottom is all the same. And if I check if my character is colliding, right? If he touches this platform, he's going to stick, right? Because he would stick on the top of the platform too. So therefore, he'd stick on this one too and on this one, right? So sometimes what we want to do is break these ones up too, right? So we have another little collider there, another little collider there, here, right? So it does different effects than the top, right? We break it up. And it might seem complex, but this is only one way to do it. The other way to do collisions is the distance formula. The closer I am to an object, if I'm really close and the center of I measure from a particular location, my legs, if the distance between the center of my legs is less than a certain amount, I can cast a ray, a line between my legs and the platform. And if it's less than that, I'm hitting the ground. What's happening over here? I don't care about this, right? I'm pointing this out to you because this is some of the ways we use collision and on collision enter, on trigger enter, and the difference between a collision and a trigger. A collider and a trigger. Collider is usually used for some kind of physics. We can use it without a rigid body 2D to detect overlap. We can do that. Typically, we separate them out. The other thing I want you to take away from this is that you can have an object have multiple colliders on one object. All you need to do is just change the offset so that you have parts of the collider on different parts of the object. So let's say, for example, I have three colliders, right, on this object. So let's say here's I'll make them bigger. So here's the head of my guy, right? My legs. I could separate this because the middle of my body is being targeted, right? But I can offset my collider so that the head has one, right? And the body has another, but it's still one object. I might want to use a circle collider, right? Sometimes it's a little better because I only have one area that I can touch as opposed to this whole surface that's colliding. Circle colliders, you might see a circle collider being used for the bottom. Talking about this because we're going back to the event life cycle, right? So here's the event life cycle. Just after initialization. This is where we have our fixed update and where all the collisions and triggers happen. Okay? I'm sorry about the theory, but we need it. Sorry, because it's not exciting. It's just something we need to talk about. We do input events, the update. So update and late update happen after fixed update. Fixed update, update, late update. That's how it goes, okay? And then we do our scene rendering. Again, we render only what's inside the field of view. We don't render anything below the near plane and outside of the far plane. Only within what's in field of view. There's too many calculations. However, everything outside of the field of view is still held in memory. Thousands of objects in my game world, right? But they're just not in the field of view. And they're not being rendered, drawn, okay? Now what that does is the more objects that are outside of my field of view that I have to keep track of, the heavier there's a lot more work the game has to do. Especially from a loading perspective, when I go, let's say we'll talk about Fallout 4 again, right? You have a guy, and I kind of made this example this morning, character, he's got a first-person perspective, and then he walks into a building, right? There's a bit of a lag. As soon as he touches the door, it makes that door animation that kind of opens up, and then it goes loading screen, right? For a lot of buildings. Why? It's a new world. Each building is a world, a scene, if you will, that you're going into, right? As soon as I touch the door, I've triggered my collision. I'm going to go to I'm transporting myself to the next scene. Now I'm in the next scene. Okay, cool. All right. I'm loading stuff in. Great. I've got all these things going on. Things that I can see and things that I can't see. Items that I can pick up. Wait, look, there's coins, bottle caps, right? In Fallout 4. I'm going to bring, as many, fine, right? Because those are going to give me money, right? Fine. Hey, there's a weapon. I can pick that up too. Those are all items that are being kept track of. In a room, the default locations for all those items have been decided, right? If you move an item in Fallout 4 or any one of those open game worlds, right, that you play, any kind of open game that you play, to the other or drop an item, it records your new location and keeps it in memory. Now that game world is updated, that scene is updated with the changes. And it happens whether it's inside or outside the field of view of the camera. Field of view of the camera tells us what we see. But outside of the field of view, lots of other stuff going on. Okay, scene rendering. Next, gizmo rendering. Gizmo is, if you think about the gizmo in Unity, which would be object, right? You see this little gizmo right here that comes on? This is a gizmo. So all this rendering and all that stuff in a certain spot, especially if I put additional gizmos and everything else inside my editor while I'm playing. So even though I'm playing the game, if I play it within Unity, it's going to have a render order for all this stuff to happen. And it's going to happen later than the actual game itself. So if I go back to the PowerPoint presentation, you can see that the render order of my UI, my gizmo, I render my UI as an example, right? And then I kind of, any kind of pausing happens here. My disable enable, if I want to disable enable objects, it happens here at the end. And finally, at the very bottom, destroy or on application quit. That's when I can destroy objects. On that, I mentioned this morning, there's two things that I can do. I'm going to kind of turn these off for a second. Object here, right, this platform. And if I instantiate new platforms programmatically as I play, an example of that would be I have a platform, and then as I walk forward, poof, another platform pops up. And if I walk forward more, poof, another, and it's programmatically. Maybe it's going to be over here. Maybe it's going to be over here, over here. My code is making it appear. All these platforms. There's processing power involved. I have to call them into being. I want you to think about calling the demon from the depths. All right, it takes a lot more energy for me to do that in real time. However, if I load all my platforms and move them where I need them, that's a totally different thing. I'm reusing my platforms, hiding them from view. Maybe I have 100 platforms, 50 platforms, wherever. And then when I need to, I just put them where I want them in my game. That's a different mechanic and a different use of memory and resources than if I instantiate something. That takes a bit of resources. The same thing with destroy. I want you to think about those two words, instantiate and destroy. They're actually keywords you can use in Unity. I can instantiate a prefab. I can destroy a prefab or an object. when I instantiate and destroy, it takes CPU resources. It muddles with CPU resources. And when I switch CPU resources around, right, I change the speed of my game. I change my performance. And I don't want to change my performance. I want to keep my performance as steady as possible. If I have bad performance, I want to have consistently bad performance. I don't want to have sometimes bad and sometimes good. It's bad. It makes it worse, actually. So I'm like, hey, what happened? Oh, but it didn't quite work, right? And then it makes me crazy. So it's better just to have a consistent level of performance all the time. Okay. Concepts here, and I'm sorry I have to do this again, but I apologize in advance because I know people don't like watching this stuff. But it's important for us to understand what we're talking about. Point, it details all the things we talked about. The things I want you to really focus on, if I was going to think, and some other examples here in terms of code as well, I want you to focus on the two main functions, which is the start function, and we're going to talk about later on, and the update function. Those are the two functions that get generated automatically. Okay, before we stop, the game object. All game objects in Unity they all have a transform component, right? So I can make a game object in Unity, and if I go to Unity for a second, let's close this down. Now we don't need this anymore. A transform object and transform component for my player. My player ship has a transform component. It has position, rotation, and scale. In Blender last week, we did Blender. Position, rotation, and scale. It has all those things. Every object in Unity has that. Even empty objects. Example, I go create empty, right? And I'm going to pull this game object over here. Notice it has only one component, position, rotation, and scale. Remove the transform component. It's part of it. Whenever I have a game object, I have to have those things, right? That's the one thing to note. Because Unity is using a component-based game object, I can add components. Notice here I have 3 components. I have my transform, which is part of every game object. I have my sprite renderer, which is another component. And the sprite renderer needs a material, which is my default material. So I can have many components, a component-based system. So if I go back to PowerPoint here for a second. So that way, that each component itself is part of the game object. The game object also has a bunch of some static properties. The variables in the game object, there's a lot of stuff we should know. Layer is the ability for us, especially from a 2D perspective, to create something in 2D space. Remember, 2D is all flat, right? So what if I take one 2D object and the other 2D object and put them on top of each other? When you enter them, that's where they appear. But you can change that order by changing the layer order in the game. And the way to see that, if I go back to Unity, player ship is a flat object. It's a sprite. I have order in layer right now is the 0, right? Which means it's the lowest level. We're going to put another object here called background. Here's my background object, right? Background, in order for me to put my background object in play, I have to do a couple of things to it. So come with me and do this with me while I do this, okay? Background object. My background object actually has stars in the background. We're going to tile this object across our background. How do we do this? 1, it's not a sprite anymore. We're going to change this, number 1. And what's a texture? A texture is just an image. That's all it is, right? Now, I can't put a texture directly into play. Part of another object. I want to apply this change because I made a change and I need to apply the change. So now my object is a texture. The second thing is this. Clamp mode for all of my textures are clamp, which means they don't repeat, right? I want mode here from clamp to repeat. I want to repeat it and click apply again. So now my background texture can repeat. It's repeatable or tileable, if you will. I need a couple things. In my assets, I want you to create another folder, all right? Here's another folder. I want to create a new folder called material. Materials, actually, is what it is. Materials. It'll be okay. I even did material this morning. Okay, here's my materials folder. In my materials folder, I'm going to double click and I'm going to add a new material. Now we're going to talk about what materials. We talked already about camera and the field of view, near plane and far plane. We're going to be talking about materials. Create material, right? That's what I've done. So what I've done is I've gone to the materials folder, right-clicked, and go material. Now it's going to make a generic material. We're going to call this the background material. Notice that our shader is the standard shader. We don't want this to be unlit texture. That's what we want, unlit texture. We want to change our shader. Shaders for materials is the way that it catches light, kind of lighting in our 2D game. Because we don't need, there's no need for shadows. There's no need for any of that stuff. It's 2D. So we're going to make our background material unlit texture. Good. And we're going to change our tiling to 25x and 25 across the y-axis. Okay, cool. And that's the second thing. And the third thing is we're going to select our texture, which we already have. Folder, we have background, right? We're going to select our texture. We're going to click select and click background. So now we have a repeating material with a repeating texture on it. Hear what I said? A material that contains a repeating texture. You cannot have a texture live on its own. Applied to a material. The material has to be applied to an object. It's almost like, think about an object material as its skin. Default skin for the material is very basic. Little reflectivity and very little other features, right? Right now, if you look at our player, our receive this material, we have a material and we have a texture, but we don't have an object to take it. We don't have a game object yet. We need a game object for our background. Okay, let's do this. So I'm going to right-click and add a new object. I don't want to add in an empty object or even a 2D sprite. I don't want to do that. I want to make it a 3D object in this case to follow the book. I'll make it a cube. And we'll change the cube's name, the name of an object. You can go click once and then click twice. That's one way of doing it. Or you can click once and then over here on the right where the inspector is, you can rename the object up here. Right-click on the object and go rename, whatever suits you. And I'll change this to background. All right. Here's what we want to do with this object, this background object. Notice that I added in a cube. What does it look like in real life? In real life, in 3D, right? It actually looks like this. It's inside my field of view, right? I'm just pointing it out to you so you guys can see this. So here it is. I'm just going to move. I'm going to rotate this a little bit this way and pull out. And again, I'm doing this so that way you guys can understand what I'm seeing, right? And what the camera sees. So I'm going to click on the camera and click F to go select that. There's my cube inside the field of view in my camera. This is where it's going to be, way in here. Where's my ship in all this stuff? Well, my player ship is kind of in there too. In fact, it's inside the cube. It doesn't work for us, right? In fact, if anything, what we need to do with the cube is move it back one. So right now, the position of the cube is 0, 0, 0, 0, 1. So we can see the cube. So we can see the plane. Right? Here's our ship. If I put it back to 0, covers the plane, right? But if I put it back, if I put a 1 behind, right? So the z-axis is into the actual object itself. Let's go back to 2D for a second. So there's our object. There's our background. But the background is kind of small, no? We need to make this background huge. Make it so that the scale of the background is 100 by 100. There we go. So massive. It's so big. You can see that it's even way bigger than the viewport. Here's our viewport. Here's the scale of this whole background. There's a method to the madness. Now remember, we wanted to repeat our material. Here's something we don't need. We don't need a box collider. We don't need a box collider for this thing. It messes up, right? So let's get rid of it. So box collider, remove component. We do need a mesh renderer for this thing, the background. And in our materials, what we're going to do, drag and drop the background material inside of a materials folder out of our default material, like this. So our default material now, right, mesh render, I've opened this little materials up here, and I dragged and dropped the background material we made inside the mesh renderer. Let's see how this looks. If I press play, I get this, some stars. See the stars in the background? They're kind of repeating all over the place. Okay, a little bit of work there. A couple other things to note before we upload this. I've added a background, and I want to upload this to GitHub again. A couple of things to note. One is when we play, I want to save my scene, first of all. Ooh, every time we do that, we want to save our scene. Next, if I go into Unity and I go into preferences, and for you, you'd have to go, I think it might be window preferences for on the PC. But if I go to preferences, notice that I have a couple things. I can decide the external tools when I do scripting is mono-develop because I have a Mac. Your external scripting is probably going to be Visual Studio. Okay? If you want to find preferences on Windows, I believe it's under the window preferences. Go to window preferences on PCs. I believe that's where it is. Preferences. Most likely it's going to be there. Is it? Where is it? On the window. On PC, where's the preferences option? Is it edit? Edit preferences? Okay, there you go. Go to edit. All right. So if you notice here on mono develop, this is the one I have, but you might have, which is what you should have. For PC, the default is Visual Studio. For Mac and for Linux, it is mono develop. Okay, here's the challenge when it comes to mono develop. It gives you some code hinting and everything else, but I can also choose Visual Studio Code if I really want to. Visual Studio Code does have support for the mono develop framework or for Unity. So if I really wanted to use a lightweight code hinting, and there's an option, Visual Studio Code is the option. I'll do it later on in this course. Colors. This is interesting. Tint right now is very much the same as my regular tint, but I probably should want to know when I'm in play mode. So my recommendation to you is when you're in play mode, change the color like light green or something. Okay, why? Let me show you why. If I press play, so go back here, and I press play, now I know I'm in play mode, green. I know if I make any changes here that I'm in play mode. If I stop play, I know that I'm in edit mode. Now, if you don't do this kind of stuff, some changes when you're in play mode, and then your changes will be lost. You can make changes in play mode, but if you do, poof, they're gone, right? All right, so some changes we made. Let's save this thing. So file, save scene, file, to, and then I want to close Unity down. So close Unity. We did this last time. And what I want to do is I want to go here into my terminal again, git add dot, git commit -m, and I'll say added background. I did. Okay, and I'll say git push. I'll do it up here so you can see it. Git push origin master, which is going to push everything to the, again, here's my workflow. I work in Unity, I add features, I get out of Unity, I record my changes on the local Git repository, and then I push it to the remote, right? And I'm doing that over and over again so that I have a record of my development at GitHub now. So I'm on GitHub, and if I click code, you can see that I got 3 commits, and here they are. My initial commit, I added my WebGL build. I guess my initial commit also included my player, right? But this is the way we've been developing our code, right? Our code base, if you will. Let's take a short break, and when we come back, I want to talk more about the input system, the game object. right? I know we're going slow, and some of you are dying they're chomping at the bit of trying to fix to get all this done, right? But the challenge is if we don't talk about this concept stuff, so when we actually start programming it, it's going to go whoosh over your head, right? So let's take a short break, 5 minutes, and we'll get back into it.